All right, you guys ready for the next one? He looks dirty. There he is. Okay, we're going to do that guy. Let's do example number 2 right now. Shh. You guys remember the trig? Remember trig stuff? Let's plug them in. We got tangent of pi over 2 up top. And then on the bottom we have secant of pi over, oh, forgot my c, secant of pi over 2 on bottom. All right, so I like looking at sine and cosine the best. So I'm going to go ahead and write tangent as sine over what? Cosine. Yeah, sine over cosine. And then we have, what's secant? That is 1 over cosine. All right, so let's see what we get. On the top, what is sine of pi over 2? Uno. What is cosine of pi over 2? Zero. On the bottom, we get the same thing. Look at that, we're dividing by zeros. This is not allowed. Oh, hey, check this out. Do you guys remember what tangent and secant look like? Let's see. Tangent goes like this. It has an asymptote right here, right at pi over 2. Why? Because look, when cosine is pi over 2, we get an undefined thing. So that's why we have this. So let's think about that for a second, guys. In terms of limits, this is my tangent graph, and we can draw more of these squiggly dudes, but we're just going around pi over 2 because that's what we're doing right here. As I approach pi over 2 from the left-hand side, it's going to positive infinity. As I approach it from the left-hand side, it's going to negative infinity. So we would have infinity on the top right here. And do you guys remember what secant looks like? Secant is related to cosine. If I draw cosine, it looks like this. Cosine is 0 right here, and it's 0 right here. So therefore, secant would be undefined. I should make this a dotted line, because that's not part of our secant graph. However, it helps us see the secant graph. Our secant graph includes these cute little parabolas at the maxes and mins of cosine. You guys remember this?
Oh, I remember.
So look at that. As I approach pi over 2, which is this guy right here, where cosine is 0, as I approach pi over 2 from the left, it's going to positive infinity. As I approach it from the right, it's going down to negative infinity. So we have infinity over infinity, which is indeterminate. So can we use some manipulation in order to do this? Some algebra? You hope not. No, you hope so, foo. Okay, let's look at this guy. Now I'm going to rewrite him because we all know how, and that is sine of x over cosine of x. That's tangent. And on the bottom we have 1 over cosine of x. Tell your neighbor right now if you know how to manipulate this so that we can test it again. Alright guys, thank you for talking about it. Now, if you said multiply it by a behemoth 1, good job. You were right. You multiply it by 1 because you cannot multiply this thing by anything else except for 1. Otherwise, you would be changing it. So I'm going to multiply it by a special one, a behemoth 1. I have cosine x over cosine x. This, my students, is a 1. Look, he's a behemoth. Yo, that 1 is so big. It's bigger than your... Look at that 1. He's so cute. Now what happens when we multiply the top by cosine? That cosine gets eliminated. He dies. Alright, slow death or fast death?
Slow.
Yeah! Ah! Oh, at the bottom. We multiply this guy by cosine. Slow death or fast death?
Silent death. Silent.
Fast death. Ah! Ah! Now, what am I left with when I multiply that?
Sine of x.
Just sine of x. It's sine of x over 1, right? So now I have the limit as x approaches pi over 2 of sine x. If I plug pi over 2 into sine x, what do I get, my students? Uno. And I'm allowed to do that because he's continuous. That's my answer.